This presents briefly a large displacement vessel barrier for the Singapore Cruise Centre. The barrier prevents a 335-metre cruise ship penetrating far into the harbour. 72,000 tonnes of displacement, or 77,000 tonnes with added hydrodynamic mass, travelling with an initial velocity of 6 knots. We stopped within 90 metres after contacting the barrier. The bow will be stopped 40 metres from the cable car line in plan view. The whole of the kinetic energy, or most of it, will be transferred to potential energy stored in TEDS systems. TEDS, the Truston Energy Dissipation System. The maximum barrier tension is around 800 tonnes. It's an elegant and robust structural design with rigorous engineering time domain simulation. A site plan drawing of the harbour is shown below, with two TEDS systems shown, one at the end of the pier here, on the west end of the pier, and one on the north side of that, with the green line representing the barrier stretched between the two of the TEDS systems. When the barrier is not in use, it's stored open to a dolphin, shown here. The Sentosa Tower is down here, and the cable car overhead is along this line. We're going to look at some time domain simulations run with the engineering program Orcaflex. The site plan is shown below here in an Orcaflex view. Orcaflex has two views. This is the shaded graphics perspective view. The Sentosa Tower is down here. The overhead cable car run is here. It's a fully three-dimensional program. The blue circle is the turning circle we saw on the site plan, and the barrier is here with the two TEDS systems. This is now a replay running in Orcaflex in the line drawing view with no perspective. It's still three-dimensional view. This happens to be a plan view. The cable car is overhead. The two TEDS systems are shown here with the barrier between. We see the ship approaching from the west, and the squiggly line here means that we've got some waves running, and they're running in the direction from south to north. The ship's impacting the barrier, and we will switch from the shaded graphics to a series of views. Sorry, we switched from the line drawing to a series of views with shaded graphics. So now you see the ship in this view pushing into the barrier, and it's going to make contact with the fendering along the pier and on the front side of the TEDS, or the north side of this TEDS, and there'll be a slight bounce off. The replay here is running at 200%, twice real speed. We can see we didn't get close to the overhead cable car run, and the closest we got here was 40 meters, one of these squares. If I set it to replay in shaded graphics, I set it to replay with showing trails, and I'll speed it through. The whole of the trails that the ship made is shown there. And you can see that this distance is one square roughly, and each square is 40 meters. The three graphs are important. This graph is showing in blue the velocity of the ship in the x direction, beginning at 3 meters per second, or 6 knots, and decreasing down to 0 from a time of roughly 50 to roughly 100 seconds, so in 50 seconds. I'm going to set the replays to just play a specified period, which is more useful. So just the period of the graph will be replaying. The red line is the barrier X deflection at the center, and each of these divisions is 10 meters. So we see from something less than 250 to 310. So that's about 70 meters, 60 meters in this case at the center of the barrier, and the ship wasn't hitting square on as we saw. Here the total tension in the barrier is being plotted with the black line, and the tension builds from a small tension when the barrier is not being used in slight tension up to, in this case, not quite 7,000 kilonewtons or 700 tons for this particular case, which is 6 knots, but it's going at not quite a square angle. So it turns the ship as the ship is slowed down and stopped, and the ship is not bounced back because the TED system stores its energy. When the barrier reaches peak tension, it stops pulling and doesn't rebound the ship back out of the system. This concludes the presentation of the ahead collision at 6 knots of the cruise ship into the barrier. There'll be another presentation on astern collision